Hi, everybody. Mary here, and we're going to talk about the law of conservation of energy. Now, the law of conservation of energy is one of those big conservation laws that is important in all of science. And it says this: energy cannot be created or destroyed, it simply changes forms. Now, this is important in all systems, mechanical systems, biological systems, our entire planet, and of course, our bodies. We talked about types of energies, and one of them is kinetic. And there are lots of different kinds of motion that we use to create energy. Simple motion of any sort. Electrical energy in motion is electric current. Sound is a form of kinetic energy. We use wind power to create electricity, and that's a form of kinetic energy. Heat itself is molecules and particles bouncing and banging into each other. Light is actually electromagnetic waves in motion, and something as simple as molecules in motion. Potential energy can be gravitational potential energy, how high something is above the surface of the earth. A coiled spring is potential energy, or coiled muscles. How far apart two molecules are can relate to internal chemical potential energy. And then the chemical potential energy in the bonds of molecules. Electrical potential energy in voltage, and the chemical potential energy in things like fuels. Now, the definition of energy is defined as the ability to do work, and as you recall, work is when a force is applied to move an object through some sort of a distance. And so there is this beautiful circle or chain. Energy is used to do work, and then energy is stored. And then again, that energy can be used to do work, and it goes around in a big, beautiful circle. So for example, this fellow uses some of his chemical energy from his breakfast to do work to lift the rock, converts that to potential energy. If he drops the rock, it can come down, hit bug down here, and apply a force on the bug. This lady uses her chemical energy from her breakfast and creates kinetic energy, which is motion, helps her climb to the top of the stairs, giving her potential energy. This person again uses the chemical energy from their food to apply a force to this car to move at a distance to give it kinetic energy or motion. This person uses chemical energy from their food to apply a force to this rubber band to give it potential energy in the form of a spring or an elastic band that could snap at any motion, at any moment. So this energy is always changing from one form to another. So what we're going to do is we're going to spend a couple minutes looking at this chain of energy. Couple different examples to give you this idea that energy doesn't evaporate or go away, it just changes from one thing to another thing to another thing. And the beauty of it sometimes is just seeing where does it go. So here's someone who eats a lovely, well-balanced meal, uses that chemical energy to create kinetic energy to ride their bicycle in the form of motion. That motion is used to climb to the top of a hill and create potential energy because it's been position. That top of the hill, then they can coast down the hill, creates kinetic energy, and some of that, all that lovely energy turns into heat. And heat can be a byproduct of all sorts of energy. Lots and lots of energy can create heat as a waste product or a byproduct. Here's another chain of energy. Raindrops have potential energy because of their position. They fall, creating kinetic energy or velocity. That rainwater is then trapped in lakes or rivers, giving them actually potential energy compared to a lower position. As they fall, that's converted to kinetic energy. And if that falling water moves through a turbine, that kinetic energy can be used to transform into electrical energy That electrical energy can be used to power a fan, which again creates kinetic energy or motion, which keeps you cold. So one form of energy transforming into another. Here's a really fun one. When you go to a amusement park and they give you this big first hill on a roller coaster, they are giving you lots of potential energy. A lot of work is done on you. A force is exerted by the chain that lifts your little roller coaster car to the top of the first hill. And at the top of that first hill, then you fall down that first hill and potential energy is converted to kinetic. You're transforming position into speed. And then you go to the next hill, speed is transformed back into position back into speed. And at the very end, they usually have to apply the brakes when you get to the very end, and then they bleed off the very last bit of energy, and that's transformed into heat, because heat is constantly there stealing energy away. Now, that law of conservation of energy is true in everyday life. And in normal chemistry, we only have to worry about the law of conservation of energy. But when you start worrying about nuclear physics or nuclear chemistry, then you have to talk about the law of conservation of mass and energy. Back in 1905, the eminent physicist Albert Einstein discovered this equation, E equals mc squared, that said that energy can be created if you can convert mass directly into energy. It's very difficult to do, and it can only be done in very specific and unusual situations. Where can it occur? Well, it only occurs in nuclear situations like the sun, in a nuclear fusion reaction inside of stars, or nuclear power plants. So you don't have to worry about this conservation of mass and energy on a daily basis in your life, but it is very important in how the universe functions. For example, our star right now is converting approximately 4 million tons of hydrogen into pure energy every second. And that is what is giving the light and the heat that is actually hitting beautiful planet Earth to keep us warm. So what's the ultimate source of energy that powers you? Well, you eat vegetables, and if you eat a hamburger, you eat some hamburger that used to be a cow that ate grass. You use that to convert to kinetic energy and motion, potential energy when you climb up things, and heat that keeps you warm. But where did these things originally get their energy from? Well, they got their energy from the sun. And where did the sun get its energy from? Well, nuclear fusion in matter. So just like Superman, you are solar powered. Yeah, you're just like Superman. And is it Supergirl? And why is it Superman and Supergirl? I don't know. All right, we'll see you next time. Bye-bye.